Okay, let's just dive right in. If you're anywhere near software engineering, you already know the pain of testing bottlenecks. I mean, how many times have you pushed some brilliant code on a Friday, only to sit around waiting until Tuesday for QA to finally clear it? You build something amazing and it just sits there, days or even weeks of expensive time, totally wasted. Well, in today's explainer, we're unpacking a genuinely groundbreaking white paper that claims to solve this exact crisis. We're looking at a system called G-Tester. And look, this is not just another basic vulnerability scanner. We're talking about a complete architecture designed to replace those traditional QA bottlenecks with a fully autonomous, multi-agent AI system. It's wild.
To figure out how this architecture actually works, here's our roadmap. First up, the QA scaling problem itself. Second, we'll look at the company behind this, AlphaCan Defense Group. Third, we're diving into the multi-agent AI boardroom. Fourth, a look at their truth-through-evidence safeguards. Fifth, the 5-stage pipeline. And finally, we'll wrap up with what this new QA paradigm means for the industry.
All right, part one, the QA scaling problem and the bottlenecks holding back modern engineering.
So we have to start with this universal pain point that every tech leader knows all too well. Traditional QA just doesn't scale. Think about it. Manual testing takes weeks of really expensive, highly subjective engineering time. You could literally have two different senior engineers review the exact same pull request and get completely different severity ratings for the exact same bug. It's crazy. Plus, teams are usually juggling a dozen fragmented tools, security scanners, load testers, UI scripts, just to get a baseline. But the G-Tester alternative? It operates as an autonomous quality assurance as a service, or QAAS. This thing executes at machine speed with deterministic consistency. That means a bug gets judged the exact same way every single time across a unified fleet of runners, handling all those fragmented tools automatically.
Moving to part two, enter AlphaCan Defense Group, the team building G-Tester.
So who's actually trying to solve this massive bottleneck? Well, grounding this firmly in reality, official UK companies' house records show that AlphaCan Defense Group Limited was incorporated in March 2026 specifically to build this platform. So this isn't just some theoretical pie-in-the-sky academic concept. It's a real enterprise-grade solution built to tackle this crisis head-on. The crucial thing to grasp here is the sheer scope of what they've built. G-Tester doesn't just run silent background scripts like your standard legacy vulnerability scanner. No, it is a full enterprise-grade quality assurance as a service. It deploys an autonomous system that actually reasons over evidence, exactly like a senior human engineer would. The white paper makes it very clear. The goal is to replace the reliance on a massive manual QA team by scaling that expertise infinitely, instead of just handing humans yet another single tool to manage. Which brings us to part three, the multi-agent AI boardroom, and our new cast of characters. The real secret sauce here is a live, multi-agent AI council. They aren't just relying on one generic do-it-all AI, which, let's be honest, is where a lot of modern automation completely falls apart. Instead, they route specific testing disciplines to highly specialized models running on an air-gapped GPU hub. For instance, you've got a massive Gemma model acting as the lead QA chair, synthesizing the debate and calculating the final verdict. But say there's a specific security flaw. That workload instantly routes to an ITDR officer model, deeply specialized in threat modeling, privilege escalation, and the OWASP Top 10. API contract issues go to a specialized coder reviewer model for static analysis, and UI and accessibility issues? Those get routed to a Qwen model built to read DOM snapshots and check WCAG compliance. By dividing the labor like this, the system guarantees that highly complex issues are analyzed by absolute domain experts.
But here's where it gets really fascinating. The creators know that fully autonomous systems usually terrify enterprise compliance teams, so they built what they call the AI boardroom. Instead of an opaque black box where you just hit run and cross your fingers, you get this live visualization dashboard that offers total transparency. There's a live agent stream where you can literally watch the AI models debate a finding in real time. You've got an evidence feed showing the raw telemetry, a doctrine inspector to verify exactly which rules the AI used to make its call, and crucially, a steering console. This lets human operators pause the run, inject custom parameters, or completely override verdicts on the fly. It basically guarantees an engineering manager is never locked out of the loop.
All right, part four, truth through evidence and the system's honesty safeguards.
Now, if you know anything at all about AI, you're probably asking the big question right now. How do we know the AI isn't just hallucinating and making things up? It's a huge risk in enterprise environments. Well, the white paper solves this with strict architectural invariance, primarily through something called graceful degradation. The system is designed for absolute honesty. If a test can't run, it explicitly reports a skip, never a pass. And if the AI inference tier completely crashes or goes offline, the system gracefully degrades back to the hard, deterministic facts collected by the runner tools. It will absolutely never invent a verdict just to push a job through. It defaults to the objective truth.
On top of that, the architecture eliminates parametric hallucination by binding the models to strict rules of engagement using a system called SRAG, or Two-Stage Retrieval Augmented Generation. Think of it kind of like forcing the AI to take an open book test, but it's only allowed to read from the company's officially approved rulebook. Using vector embeddings, it grabs relevant QA rules from a curated house doctrine, and then a cross-encoder rigorously ranks them for precision. So the AI isn't just blindly guessing based on its general internet training data, it is explicitly anchored to strict, documented operational rules defined by the enterprise.
Moving right along to Part 5, the 5-stage pipeline, going from raw telemetry to a final verdict.
Let's look at the actual execution flow to see how a bug travels through this massive setup. Step 1. Raw data is generated by the evidence layer using standard runner tools. Step 2. That data hits the AI Council for deliberation where our specialized models weigh in. Step 3. The AI grounds its logic in the doctrine RAG we just talked about. Step 4. Everything gets compiled into a professional package and final verdict. And Step 5, and this is super important, there's a self-learning debrief loop. This ensures the system actually learns from its own verified runs to improve future testing while completely sanitizing the data to protect client privacy.
Zooming in on that very first step for a second, that initial evidence layer isn't just running one or two basic checks. It spans an impressive 20 distinct testing disciplines. The system is orchestrating real, heavy-duty industry tools under the hood. It spins up K6 for high-throughput concurrent load testing. It uses Playwright for deep cross-browser end-to-end user journeys. It even uses a read-only shell collector for deep OS infrastructure audits. It generates a massive mountain of real, unarguable telemetry long before the AI ever gets involved in the reasoning process.
And when we finally reach Step 4, the final verdict, the AI is actually locked out of the final release call. To ensure total reliability, the release decision is an unfudgeable, deterministic function based strictly on the highest severity finding uncovered. The AI can't soften the blow, it can't hallucinate a quick fix, and it certainly can't be convinced to pass a failing grade. If the function sees a critical flaw, it halts the release and flags it as not ready, period. If there's a high or medium flaw, it caps the verdict at ready with caveats. A build is only marked production ready if there are exclusively low or info-level findings. It's incredibly strict, which is exactly what you want guarding your enterprise release cycle.
Finally, Part 6, a new QA paradigm, looking at the impact and economics.
So what does this all mean for the broader enterprise landscape? Well, because GTester scales horizontally just by adding cheap server nodes, it can seamlessly handle tens of thousands of concurrent audits, and the economics of that are absolutely staggering. We're talking about operating at just 50% of the lowest region human QA market rate. It completely disrupts classical labor models by delivering principal-level engineering reasoning at literally half the cost of the absolute cheapest manual testing alternatives available globally. And throughout all of this rapid scaling and cost-cutting, the system operates under one supreme rule, penned right at the very top of its AI doctrine: test like a principal engineer, report like a professional. This acts as the system's North Star. It demands that automated scaling never, ever sacrifices the deep reasoning, the actionable or remediation advice, or the sheer honesty of a senior human professional. As we move into this new era of autonomous evaluation, it's really worth asking, how will entirely removing the testing bottleneck change the way your own organization builds software? I mean, if you no longer have to wait weeks for a manual QA cycle, and you get principal engineer-level scrutiny on every single commit within hours or even minutes, how much faster could you innovate? It's a massive paradigm shift, and the architecture we've explored today proves it's no longer just science fiction. Thanks for joining me for this explainer, and keep exploring.